Welcome to our presentation, our system analysis and design final project. So the title of our final project, which is flight ticket booking system. This is our group member list. We got Itisham, Nakil, Danish, and me. My name is Dio and Raja, and last one is Zuhami. The airline industry has experienced rapid digital transformation, with online flight booking system becoming an essential service for passengers worldwide. Customers now expect a fast, convenient, and user-friendly platform that allows them to search for flights, service seats, make bookings, and manage their travel plans efficiently. To meet this expedition, airlines require well-designed information systems that streamline booking operation while improving the overall customer experience. This project focused on the analysis and design of the AirAsia flight ticket booking system, a centralized web-based platform that enables passengers to search for available flights, register user confirmation, and in addition, the system provides administrative functions for managing flight schedules and monitoring booking information. This project emphasizes system planning and system rather than software development, ensuring that all functional requirements are clearly documented before implementation. And the project adopts the waterfall model as its system development methodology due to its structure and sequential approach. The methodology guides the project through the planning, analysis, and design phase, resulting in a comprehensive set of system artifacts, including the project charter, work breakdown structure, context diagram, data flow diagram, enhanced entity relationship diagram (ERD), and user interface design. These developers provide a complete blueprint of the proposed system and demonstrate how the various components interact to satisfy user and business requirements. Overall, this report represented a systematic analysis and design of the AirAsia flight booking system, highlighting the importance of effective system planning in developing reliable, efficient, and user-oriented information system for the airline industry. Next on, we got a problem statement. Many passengers experience difficulties while booking flight tickets due to the scattered information, time-consuming process, and limited process management features. At the same time, airline administrator may face such challenge in managing flight schedule and booking record efficiently. Therefore, a centralized web-based flight ticket booking system is needed to simplify the booking process, improve data management, and provide a better experience for both passenger and administrator. Our objective of the final project to design a centralized web-based platform for passengers to search, book, and manage flight tickets while providing administrative tools for the flight scheduling. Our scope of the project. So we got an in scope and an out of scope. Our in scope is user registration, real-time flight search, seat selection, booking confirmation, and admin flight management. Our out of scope, which is real-time payment gateway integration, crew scheduling, and in-flight meal inventory. Our project significance. The flight ticket booking system is important because it helps the airline manage passenger information, flights, and booking more accurately by using a centralized database. The system removes repeated records and reduces the errors when customer details change. The system also improves daily operations by preventing double booking, blocking the deletion of flights that already have reservation, and speeding up flight search. This makes the booking process more reliable for both customer and staff. Finally, the system allows the airline to set different price for the economy, business, and first class seat, helping the company manage revenue more effectively. Overall, the system improves accuracy, saves time, and provides a smoother booking experience for everyone. That's all from me. Thank you.
Hello, I'm Raja and I will be continuing this presentation into the chapter 2, which is the work breakdown structure WBS. So for the 2.1, we have the Gantt chart. So as stated in the slide presentation, we have the ID, task name, duration, and dependency. Okay, the explanation of the Gantt chart is the Gantt chart presents the project schedule for the development of the AirAsia flight ticket booking system. It outlines the major project activities, their durations, dependencies, and planned timeline. So, this schedule helps ensure that each phase is complete in the correct sequence and allowing the project to be completed efficiently within the allocated time frame. So this is the PERT chart analysis. So the path is A to B to C to D to E to F and to G. So the longest path duration is 25 days. The critical path is the every task in the sequence is critical. So any delay in the DFD design, which is task CD, will directly crash ERD and UI design timeline. So here is the Gantt chart.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Muhammad Itisham Farullah bin Faisal, and now I will explain the context diagram for our AirAsia flight ticket booking system. So, a context diagram is used to show the overall interaction between our system and the external entities involved. Instead of showing every detailed process, it presents the system as one main process and focuses on the data that enters and leaves the system. In our case, the AirAsia flight ticket booking system acts as the central system, and it can communicate with users and other external services to support the flight booking process. Next, there are four main external entities in the system, which are the passenger, administrator, payment, and email or SMS notification system. So, the first entity is the passenger. The passenger is the main user of the system. They can register an account, log in, search for available flights, select a seat, make a booking, and submit payment information. In return, the passenger receives important information from the system such as flight details, seat availability, booking confirmation, booking status, and e-ticket. Next, the second entity is the administrator. The administrator is responsible for managing information in the system. For example, the administrator can manage flight schedules, update flight information, update seat availability, and monitor booking activities. The administrator also receives report from the system such as booking reports, passengers manifests, and flight statistics. So the third entity is the payment system. It receives payment information or payment requests from our booking system. After processing the transaction, it sends the payment status back to the system. For our project, this payment process is only a simulation. So the last entity is the email or the SMS notification system. This system receives notification requests from the booking system and sends messages to the passengers such as booking confirmations, payment receipts, e-ticket notification, and lastly, flight alerts. Next, I will be explaining our context diagram. This diagram shows how information flows between the AirAsia flight ticket booking system and the external entities. And I will explain in full details. At the center, we have process 0, which represents the AirAsia flight ticket booking system. On the left side, the passenger sends several types of information to the system. This includes registration details, login details, flight search requests, passenger details, seat selection, booking requests, and payment information. And after the system processed all of these informations, it sends back flight information, seat availability, booking confirmation, e-ticket, and booking status to the passenger. At the top, the administrator provides flight schedule details, flight updates, and seat availability updates to the system. The system then provides the administrator with booking reports, passenger manifests, and flight statistics. On the right side, the system sends a payment request to the payment system, and then the payment system processes the payments and return the payment status, either successful or unsuccessful. At the bottom, the system sends booking confirmation, e-ticket notification, and flight alerts to the email or SMS notification system. This notification system will then send the messages to the passenger. So, this context diagram helps us understand who interacts with the system and what information is exchanged during the booking process. Lastly, I will be explaining the transaction requirements. First, passenger can search for available flights based on their departure location, arrival location, travel date, and seat class. Once the passenger chooses a flight and a seat, the system creates a booking record. This record connects the passenger, the selected flight, and the selected seat. Before confirming the booking, the system checks the seat availability, and this is important to make sure that the same seat is not booked by more than one passenger. After that, the system processes the payment transaction and then records the payment details and confirms the booking only after the payment is successful. The system also supports booking updates and cancellations. When a booking is updated or cancelled, the system will adjust the booking status, seat availability, and payment record. Lastly, the system provides report transactions, and the administrator can retrieve information such as the booking history, flight occupancy, revenue summary, payment reports. These reports are used for monitoring and analysis, and they do not modify the stored data. That's all from me, and I will pass this to my other group members. Thank you so much.
Assalamualaikum dan salam sejahtera. Saya Nakidin Hadif akan membentangkan bahagian 2.3 iaitu Raja Aliran Data DFD tahap kosong bagi sistem tempahan penerbangan kami. Kita mulakan dengan proses 1.0 User Account Management. Proses ini mengendalikan fasa pendaftaran dan security log masuk pengguna. Entiti passenger akan membekalkan registration details and login details ke dalam sistem. Seterusnya, proses ini akan mengesahkan maklumat tersebut, menghantar respon registration confirmation serta login status kembali kepada passenger dan menyimpan user data tersebut ke dalam D1 User Database. Seterusnya, setelah berjaya log masuk, pengguna boleh mengakses proses 2.0 Flight Search. Di sini, passenger akan menghantar flight search request. Sistem akan bertindak memanggil flight data dari D2 Flight Database dan memaparkan maklumat penerbangan atau flight information kepada pengguna. Apabila pengguna memilih penerbangan tertentu, flight detail tersebut akan disalurkan ke fasa seterusnya iaitu proses 3.0 Seat Selection. Dalam proses 3.0, pengguna akan melakukan input select seat. Sistem akan menyemak seat availability dan memaparkan kepada pengguna. Sebaik saja tempat duduk disahkan, sistem akan menghantar parameter Store Seat Selection untuk dikemaskini ke dalam D2 Flight Database. Manakala maklumat penerbangan diteruskan ke modul pengurusan tempahan. Seterusnya adalah proses 4.0 Booking Management yang bertanggungjawab memproses transaksi akhir. Proses ini akan menerima flight detail dari fasa pemilihan tempat duduk serta memanggil data inventory terkini dari D2 The Flight Database. Apabila passenger menghantar booking request, proses ini akan menjana booking confirmation beserta e-ticket secara automatik kepada pengguna. Segala rekod transaksi atau booking details akan disimpan secara kekal ke dalam D3 Booking Database. Akhir sekali, sistem kami dilengkapi dengan modul kawalan dalaman melalui proses 5.0 Flight Administration yang dikendalikan sepenuhnya oleh pihak administrator. Pihak pentadbir akan memasukkan data penting seperti seat availability update, flight schedule details and juga flight updates. Proses pentadbiran ini secara holistik akan membaca data dari D2 Flight Database dan D3 Booking Database. Hasil daripada integrasi data ini, sistem dapat menjana output kritikal seperti booking report, passenger manifest dan flight statistik untuk kegunaan pengurusan. Sebarang perubahan data oleh admin akan dikemas kini semula ke dalam D2 dan D3 data stores bagi memastikan integriti data sentiasa terpelihara. Sebagai kesimpulan, kelima-lima proses utama ini saling berintegrasi bagi memastikan kitaran data daripada pendaftaran pengguna, pemilihan tiket sehinggalah ke fasa pengurusan admin dapat beroperasi secara sistematik dan efisien. Sekian sahaja pembentangan daripada saya untuk bahagian DFD tahap kosong. Terima kasih.
Dan berikut adalah data flow diagram level kosong.
Good morning and afternoon everyone. My name is Muhammad Zailmi and today I will be presenting the FD level 1 and the enhanced relationship diagram or ERD for our flight ticket booking system. So first let's look at our DFD level 1. It provides a more detailed breakdown of the main process in the system and it explains how data flows between user, process and database. The main modules include user registration, seat selection and the booking engine. Each process receives input from the user, process the information and store and retrieve data from the appropriate database such as user database, seat database and booking database. This detailed view helps us understand how the system operates internally. Okay, so the next slide is the enhanced entity relationship diagram or ERD. The ERD illustrates the database structure and relationship between the different systems in our system. In our system, the main entity are user, passenger, admin, flight, seat and booking. The user entity is the supertype while passenger and admin are subtype with their own specific attribute. In addition, one flight can have many seats and many booking while passenger can make multiple booking. This relationship ensures that data is well organized, consistent and free from unnecessary duplication. So, in conclusion, I think the FD level 1 explains how data move through the system, while the EARD define how the data is structured and related within the database. Thank you.
And hello, my name is Dan Shafi, and finally I'll be explaining the input and output design. For the input design, which is for the user login, we prioritize the secure authentication gateway. The high fidelity input design maps directly to the schema attributes defined in the user table of the database schema. There are three designs that we prioritize for the user login. Firstly, registered email address that captures field mapping directly to the email attribute within the user entity. Second, security password where the input characters map within encryption to the password database field. And finally, split panel layout. For the split panel layout, it focuses on the left side for the brand identity, while the right panel ensures high contrast accessibility by using placeholder parameters and quick onboard login controls. Next, for the output design, which is the body pass, where a user will receive the body pass once they have met for the booking reservation. Upon booking verification from the process 4.5, the engine dynamically compiles persistent variables into an active card. Based on the boarding pass given, there are three main points that are included, which are flight ID, passenger seat number, and set box selection on the side for adjustable for user. For the formulas for ticket fare calculations, we use for the plain P base, which is the price base of a normal ticket price for any destinations that user can book for, and in addition for seat class premium, which if user wants to upgrade it to the premium class, it will be added to the sum or the price total. And that is all. Thank you. We welcome questions on our system analysis and design documentation, processes, DFD models, database EERD schemas, or input/output interface structures for the AHR booking system.